Hello everyone. Welcome back to Dr. Lou's VCE Chemistry channel. Today, let's learn together about the 2021 VCE Chemistry examination. We will focus on questions related to volumetric and chromatographic analysis. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. A standard sodium hydroxide solution titrates the concentration of ethanoic acid. This titration is repeated until 3 concordant titers are obtained. The question is related to systematic error. A systematic error is consistent for all the titrations. The only consistent error is the difference between the actual and stated concentration of sodium solution. If the burette tap is not correctly assembled or not correctly performed, the burette tap could leak. So, A is a mistake. Options B and C are random errors. 3 different concentrations of an organic acid were titrated against a standard co. The volume of these samples was the same, so the larger the average tire, the greater the concentration. Sample 3 was the most titration volume, so it is the most concentrated acid. However, all 3 titrations cannot give concordant titers, so the data were not valid, and D is incorrect. DKP is one of the products of aspartame breakdown, and HPLC was used to analyze the concentration of DKP in soft drinks. The pure aspartame and DKP were used to calibrate HPLC. Please note their retention time. To investigate the rate of production of DKP at different storage temperatures, Kim incubated samples at different temperatures for 1, 2, and 3 days, and then the concentration of DKP was measured with HPLC. Aspartame is sweeter than sugar at the same energy. So, less aspartame is needed to achieve the same sweetness value and therefore less energy, calories, is provided. The rate of production of DKP from aspartame and lemonade at different storage temperatures was investigated here. So, the dependent variable is the rate of production of DKP. Since the rate of production of DKP is measured or expressed as a change in concentration or amount of DKP over time, they also are dependent variables. HPLC does not give the concentration directly. The peak areas must be calibrated with a standard. So, the peak area of HPLC is calibrated with the standard DKP under the same conditions, then, draw the standard curve with peak areas versus concentration of DKP. Measure the peak areas of DPK in samples and convert these peak areas into the concentration of DKP. The peak areas of DKP in samples must be within the range of the standard curve. Since the retention time of DKP is very near that of aspartame, their peak could be mixed, which increases errors. To separate these 2 peaks, we should increase the length of the column, alter the mobile or stationary phase, or the temperature of the column. Measurement errors occur due to the overlap of the 2 peaks. If any of the stated factors in Part 9c are altered, this can result in improved separation/resolution of peaks in an HPLC. Improved resolution of peaks leads to a more reliable analysis of peak areas and subsequently the concentrations of aspartame and DKP. As the temperature increases, the concentration of DKP increases generally, and the concentration of aspartame decreases. However, these trends are not followed at 15 degrees. HPLC cannot measure the initial concentration of DKP and aspartame and vary. Kim just measured them in 1 can, and used it for all 3 cans. The batch of cans could be controlled better. Kim should use the same batch of cans. The lack of initial concentration values means it cannot be assumed that the starting concentrations of aspartame and DKP were the same in each can. Therefore, the final concentrations cannot be relied upon as a measure of the production of DKP, hence the experiment's validity is compromised. The concentration of DKP and aspartame may be different in different batches. 2 multiple-choice questions are awarded 2 marks, and 1 short answer question 11 marks in volumetric and chromatographic analysis. The overall score for this section is 13 points. With a total possible score of 120 points, the percentage for this section was 10.8% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel and Lou's VCE Chemistry channel.